Hello and welcome to another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 3 lesson number 1 on direct variation. So Unit 3 is our unit on linear functions and linear modeling. And this starts by looking at a very common topic that you've seen for quite a few years known as direct variation. So let's jump right into that and eventually we'll see how it'll form the basis of all linear functions. All right, direct variation is a pretty simple idea. Two variables have a direct or proportional relationship, either way, if for every ordered pair xy we have y divided by x is equal to k, or rearranged, y equals k times x. So at the end of the day, what direct variation just means is that one of the two variables is always just a multiple of the other. So y is twice x, or y is 1/3 x, or y is 5/2 times x. Y is always some multiple of x, or when you divide y and x, you always get a constant. So let's kind of see how this plays out in a variety of different problems. Okay? Exercise 1, this is the most basic thing you can do with direct variation. It says, in each of the following, y and x are directly related. Solve for the missing value. So y is 15 when x is 5. What is y when x is 9? Now, one way to do this is to simply set up a proportion, right? Which is that y divided by x always must be a constant. In which case 15, if I take that y and I divide it by this x, is to 5, as my unknown y is to 9. Of course, we can then multiply both sides by 9. All right. We could even divide this into this and get 3, and we could get y equals 27. Now, some of you might automatically have said, well, y is equal to 27, because it's clear that here y is simply 3 times x, right? The relationship here is y equals 3 times x. And therefore, right, when x is 9, y would be 27. That's pretty clear. X is 5, y is 15, not too tough. Here it's a little bit trickier. When x is 4, y is negative 6. That's not nearly as easy of a relationship, you know. Y equals what times x, right? I mean, the question mark there, you know. So this is where that proportionality works quite well. If we put negative 6 is to 4 as y is to negative 10, well, then it's not that bad. Some of you may have the urge to just cross multiply. Of course, that's okay, but there's no real need to. Eventually, we'll get y equals 60 divided by 4, so y is 15. All right, let's do one more. And again, this one's a little bit weird, you know. I mean, what would we have to multiply 16 by to get 12? Well, there's definitely something out there. It would be 3/4, but for right now, let's not worry about it. Again, the idea is if I took that y and I divided it by its x, 12 divided by 16, I'd have to get this y divided by this x, 24. Again, I can multiply by 24 on both sides. Okay, here maybe do a little bit of simplifying. 8 goes into that 3 times. It goes into that 2 times. So y will be 36 divided, 3 times 12 is 36, divided by 2. Y is 18. All right. So directly proportional means that when you divide y and x, you always get the same number. We can use this to sort of produce missing y values. Okay. So pause the video now and write down anything you need to. Okay, here we go. Let's get into some applied problems. Exercise 2. The distance a person can travel varies directly with the time they've been traveling if going at a constant speed. So if I'm driving at a constant speed, then how far I go in terms of miles is directly proportional, or varies directly, with how long I've been driving. If Phoenix travels 78 miles in 1.5 hours, going at a constant speed, how far will he travel in 2 hours at the same speed? Okay, so this is a situation where we know one y value, we know one x value, and then we know a second x value. So it's kind of like y1, x1, and then we have x2. and we're looking for y2, right? See if you can set up a proportion to figure out how far Phoenix will go in 2 hours. All right, well, let's go through it. We can take the approach that we did in the last problem, right? We'll put 78 divided by 1.5, and that's going to be equal to that y value I don't know after 2. Again, I can multiply both sides by 2. All right, and ultimately speaking now, I just have to work this out on my calculator, right? That's all I have to do. Now, if you wanted to do 2 times 78 kind of as an intermediate step, you could. That would be 156 divided by 1.5, and that's equal to 104 miles. All right, Phoenix drove 104 miles in 2 hours. All right, let's clear this out. Pause the video now if you need to. Okay, here we go. Exercise 3. Jenna works a job where her pay varies directly with the number of hours she works. She has worked. In 1 week, she worked 35 hours and made $274.75. How many hours would she need to work in order to earn $337.55? Again, direct proportion problem. Why don't you go ahead and play around with it, okay? Now, in my mind, in a certain extent here, you're given x1 and you're given y1, and then you're given y2. It doesn't really matter what you call the variables, though. You can easily do 274.75 divided by 35 equals 337.55 divided by that input that we don't know. How many hours did she have to work? Here, I think cross-multiplying is actually kind of helpful because we'll get 2, right, so a little cross-multiplying. We'll get 274.75 times x is equal to 35 times 337.55. All right? Now what we can do is we can then divide both sides by the 274.75, and we can simply figure out what this calculation is equal to. That comes out to be exactly 43 hours. All right, just have to be careful with our calculator work. All right, so we got these ratios, right? Now what I'd like to do is I'd like to take it out of the applied realm and go back to just the pure algebraic realm where we start to kind of look at what these relationships look like when graphed. All right, so pause the video now and write down anything you need to, and then we'll move on to that. Okay, here we go. All clear. Exercise 4. 2 variables, x and y, vary directly. When x is 6, y is 4. The point is shown plotted below. So here's that point, right? The point 6, 4. Okay. It says find the y values for each of the following x values and plot each point and connect. So why don't you go ahead and do that, all right? So in other words, set up some ratios like we did before, maybe kind of divide it off, figure out the y values that go with those x values, and then we'll plot them, okay? Pause the video now and take a little bit of time. All right, well, here we go. Y is 4 when x is 6. So when x is 3, what's y? Well, you may have already kind of figured out a nice way to do this, but again, if I just kind of move on and do that, I'll get y is 12/6, so y is 2. So we have the point 3, 2. That's cool. Let's do -6. Again, we've got 4 is to 6 as y is to -6, in which case we'll multiply by -6 on both sides, and we'll get y equals -4. Hey, look at that. -6, -4. Right there. Plot each point and connect. I think I'll connect with a nice straight line. All right, there it is. Maybe put some arrows there. And look at that, we have a nice linear relationship. It says, what is the constant of variation in this problem? What does it represent in the line? Well, remember, the constant of variation is what we get when we divide y and x. So we can choose any two y and x values we want. I'll just start with the ones that we were given. 4 divided by 6, that's 2/3. Now, what does the 2/3 represent about this line? Think about that for a minute. Did you figure it out? It represents its slope. That's all that constant of variation is. Watch, let me do it in blue. Let me pick this point and this point. Do you see it? Right? If I go to the right 3 and up 2, to the right 3 and up 2, so that constant of variation is simply the slope of the line. Notice it says write the equation of the line. That's real easy. Watch. We'll just do y divided by x is equal to 2/3. It always is. And then we'll just then we'll just multiply both sides, apparently by the wrong variable. And the equation of our line is y equals 2/3 times x. That equation describes every point that lies on that line. All right, well, pause the video now, and then we're going to clear this out and keep working. Okay, here it goes. All right, back to a little application. Exercise 3. The miles driven by a car, D, varies directly with the number of gallons, G, of gasoline used. Okay, so we got gallons of gasoline and the number of miles that we've driven. Abigail is able to drive 336 miles on 8 gallons of gasoline in her hybrid vehicle. Good for her. Calculate the constant of variation for a relationship. Include proper units in your answer. So do this for a minute. Pause the video and calculate that constant of variation. All right. Well, we could take any pair that we had, but we only have one pair. 336 miles, 8 gallons. And when we do that division, we get 42 miles per gallon, right? 42 miles per gallon. Letter B, give a linear equation that represents the relationship between D and G. Express your answer as an equation solved for D. All right, well, this is similar to the last problem. D divided by G equals 42. Therefore, D must be 42 times G. In other words, if I told you I used 3 gallons of gasoline, how far did I drive? You could say, well, 42 times 3 and get, I guess it would be 126 miles. And there you go. Letter C, how far can Abigail drive on 6 gallons of gas? Well, that's the point of an equation, is to use it to predict stuff. So I'll just take that 6 and substitute it in, and I'll find that Abigail can drive 252 miles. Letter D, how many gallons of gas will Abigail need in order to drive 483 miles? Well, in that case, we're given the value of D. D equals 483. So I can substitute that into my equation. 483 equals 42 times G. So G will be 483 divided by 42. And she's going to need 11.5 gallons. Don't forget those units. All right, so this is a neat situation where we can look at something that we should feel kind of comfortable with a proportional relationship. I love that proportionality constant, 42 miles per gallon, right? That's your car's fuel efficiency, right? A lot of times the units on these proportionality constants can give us a nice physical feel for what's going on, miles per gallon, right? All right, well, I'm going to clear this out, so pause the video now if you need to. All right, and let's wrap it up. So proportional relationships, or direct variation, right? A very important topic. It's used a lot in the real world, where one variable is always proportional or a multiple of another variable. Distance and time are a great example when you're moving at a constant speed. I like that last exercise where we had the the number of miles we could drive being a directly proportional relationship with the gallons of gas we use. So there's a lot of situations, and what's important is that they form lines, all right? Lines that go through the origin, but they form lines. In the next lesson, we'll start looking at lines that, well, that don't just go through the origin. All right. For now, I want to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. I'm Kirk Weiler, and until next time, keep thinking and keep solving problems.